In this lesson, we will begin investigating about slope and just kind of talking about the basics of it. Excuse me. We know that slope describes the slant of a line, okay? That's what slope is. It gives you some information about the slope or the slant of a line, okay? So what is slope? I'm just going to say this. It's the slant of a line. Okay, there's other ways that we should be able to define it too. And you're probably familiar with some of these ways. One way that you've probably seen it defined is rise over run. Okay, your rise is your up-down part and your run is your left-right part. Okay, so rise over run. Another way you've probably seen it is change in y over change in x. Okay, you've also probably seen it as this, y2 minus y1 over x2 minus x1. You have probably, maybe you have not, maybe you have, but this is another way to say it. Delta, that's what that symbol means, is delta y over delta x. Delta means change in. So it's another way to write the change in y over the change in x. You might even just simply know it as the rate of change. Okay, that's another way to think about slope, the rate of change. You might know it as the vertical change over the horizontal change. Many, many, many ways to think about slope. But those are some of the basics that you probably should be familiar with, okay? Now, but when I do slope, I like to kind of tell a little story. There are lines that have 4 different kinds of slope, okay? So I will go through this and we will sort of draw pictures. There are lines that have positive slope. There are lines that have negative slope. There are lines where the slope equals 0. And there are lines where the slope is undefined. Okay. And to help you remember what these lines look like and how they go, I like to kind of tell a little story, okay? So what I'm going to think about is I am going to think about drawing a line. And remember, you always read left to right. So I'm always going to draw a man on the left side of my line, okay? So if I draw a little man, I'm not a very good artist, and a line that goes like this. The only way for that guy to stay on the line is to climb up, climb in the positive direction and go up, okay? Positive means you're moving up. So a line that tilts this direction like this does has positive slope, okay? If you draw a little man and you want him to go down or have negative slope, the line has to go this way, okay? If you draw a little man and you want him to not slope at all, then the line has to be horizontal and have a slope of 0. He's not going to go up, he's not going to go down, he's just going to have a slope of 0. Then, if you want this guy to become undefined and sort of fall to his death, what he has to do is go like that. Okay? So vertical lines have slopes that are undefined. Okay? So positive slopes move up and to the right. And with a positive slope, just so you know, it might be helpful to write this. As x increases, y increases. Here, as x increases, y decreases. Okay? Just so you know. All right. And we're going to leave the other two because we'll talk about them later. All right, so here I am asking you to find the slopes of the lines, or slope of 2 coordinates, okay? I don't have a graph of them in this case, I only have 2 coordinates. Most of you remember this formula right here, y2 minus y1 over x2 minus x1. Okay, important to know that your y's go on the top. Every definition we gave for slope had vertical change over horizontal change in some sort of way, whether that was a symbol we used, a formula, rise over run, whatever. In all cases, you need your up-down change on the top and your left-right change on the bottom. So these x's are here. This is the first x, this is the second x. This is the first y, this is the second y. It does not matter which one you call the first ones and which ones you call the second ones, but one coordinate has to be either both x1 and y1 or x2 and y2. So I couldn't call this one x1, but this one y2. Okay, that can't happen. All right, anyways, change in y's over change in x's. So I'm going to subtract my two y values. Oops, 4 minus 2 over my two x values, 3 minus negative 1. If you start with 4 on the top, then you have to start with its partner, which is 3 on the bottom. If you did it the other way around, that's fine, but you just have to do it in the same order both times. So 4 minus 2 is 2. 3 minus negative 1 is 4, and I want you to reduce that fraction to get 1/2. All right, here is another one. Again, I'm going to do vertical change over horizontal change. So I am going to just subtract my two y's on the top, negative 1 minus negative 2. Okay, notice I started with this one on the top, so that means I have to start with this one on the bottom. Negative 4 minus negative 1. Boom, boom. Negative 1 plus 2 is 1 on the bottom. Negative 4 plus 1 is negative 3. And my slope would be negative 1/3. All right, again, vertical change on top. So my y's go on top. So I'm going to start here with 8 minus 8. And then on the bottom, negative 4 minus 3. 8 minus 8 is 0. Negative 4 minus 3 is negative 7. 0 divided by any number is 0, okay? So what I know then is this is a line that has a slope of 0, so I know that my line has to go like this, which is a horizontal line, okay? And I should go back and talk about that on these other ones. This one has a slope of negative 1/3, so I know my slope is tilting this direction. This has a slope of positive 1/2, so I know my line goes this direction. All right, and then to the last one, again, vertical change on top. So 7 minus negative 9. And since I started with 7 on top, I have to start with a 5 on the bottom. 5 minus 5. Boom, boom, I have 16 over 0. You cannot divide by 0. So when 0 is in the denominator, then you can't divide by 0, and so your slope is undefined. And what I know when my slope is undefined is that I know that I'm dealing with a vertical line of some sort. Okay? And that is it for here.